Algebra 2, Lesson A. This is the second part, which is C and D, review of absolute value and properties and definitions. Okay, so we'll start with the review of absolute value, and we need to talk about numbers. A number is an idea, whereas a numeral is a symbol or collection of symbols. So a number is something that represents a quantity, whereas a numeral is the actual number that we're used to seeing. It's a symbol that represents how many that you're seeing. So for example, 3 is a symbol that represents 3 objects. This is also considered a numeral. 7 plus 8 divided by 5 is also equal to 3. 2 plus 1 is equal to 3. 12 divided by 4 is equal to 3. And so on and so on. All of these are numerals that represent the number 3. So if we're talking about 3, 3 can be written as a positive or a negative number. The numerical part of this is 3. It's also known as the absolute value. So the absolute value of a number is the distance from 0 on a number line. So the absolute value of negative 3 is 3. The absolute value of 3 is 3. So in our definition would be, if x is greater than 0, then the absolute value of x is x. So for example, if x is 3, it's bigger than 0, so the absolute value of 3 is 3. If x is equal to 0, then the absolute value of x is equal to x. So if x is 0, the absolute value of 0 is 0. And if x is less than 0, the absolute value of x is negative x. So for example, if x is negative, the absolute value of x is the opposite of x. So if it's negative, the opposite of that is going to be positive. If you have the absolute value of negative 15, x is negative 15, we want to do the opposite of negative 15, which is positive 15. So if x plus 2 is less than 0, or in other words, if it's negative, the absolute value of x plus 2 is going to be the opposite of that. So for example, let x equal 5. So negative 5 plus 2, the opposite of negative 5 plus 2 is going to be positive 5 minus 2, which is 3. The absolute value of 0 is 0. The absolute value of negative 5 is 5. The absolute value of 5 is 5. The absolute value of negative 2.5 is 2.5. Example. Simplify. The absolute value of negative 4 minus 2 plus the absolute value of negative 5. So the absolute value of negative 4 is 4. There's a negative before that, so we get negative 4 minus 2, and the absolute value of negative 5 is 5. So negative 4 minus 2 plus 5, we get negative 6 plus 5, which is negative 1. Okay, now we'll talk about properties and definitions. A property describes the way something is. It can't be changed. So 3 plus 2 is equal to 5, it's always going to be equal to 5. 2 plus 3 is equal to 5, it's always going to be equal to 5. And the order doesn't change the answer. If we have a plus b is equal to b plus a, that is the commutative property. Okay, definitions are things that have been agreed upon, usually agreed upon by scientists and mathematicians. 3 squared means 3 times 3. Somebody said that this symbol, 3 raised up to the second power, means 3 times 3. It could just have easily been decided that 3 squared means 3 times 2, but in our vernacular, in our symbolism, it didn't have that definition. So, for example, if you have negative 3 to the second power and negative 3 raised to the second power, they have different meanings because the first one has a negative on the outside and the second has a negative on the inside. Negative 3 squared means negative 3 times 3 equals negative 9, whereas the second one means negative 3 times negative 3. So let's do an example. Negative 2 cubed minus 2 squared minus negative 2 squared. Negative 2 cubed is negative 2 times negative 2 times negative 2 minus 2 times 2 minus negative 2 times negative 2. If we have 3 negatives, then it's going to be negative, and we get 2 times 2 times 2 is 8. 1 negative means it's going to be negative 4, and then 3 negatives again will be negative. 2 times 2 is 4. Negative 8 minus 4 is negative 16.